Hello, everyone. Thank you so much, Nathaniel. That was honestly a very, very kind introduction. I feel humbled. Come on. All right. Dad jokes don't land very well here. Good to know. All right. Okay. So today, I'm very excited to be in Berlin with you all. It's my first time in the city, and it is so aesthetically pleasing. The vibes are honestly immaculate, especially with the snow. I'm very excited to be talking about this concept of humble views. We're going to be looking at how you can architect your React and React Native applications to hopefully make it a bit easier to test and also make your applications more scalable. A little bit about me. Like Nathaniel mentioned, my name is Mo. I head the mobile team in the UK for Theodo. So Theodo is a global consultancy with over 700 digital experts, 150 of which do React Native / React. So we've been doing React and React Native from the very early days of when they came out. And as a result, we've kind of gone through phases of evolving and seeing different code bases and seeing different patterns and trying to find ones that last a long time and are scalable. And hopefully we can share some of that with you today. So testing is a contentious topic. People typically fall into two camps. If you go down the software craftsperson route, you get the likes of Bob Martin, who deeply believe that you need to be aiming for 100% test coverage, that high test coverage is the cornerstone of a good quality code base. So this is the traditional view, and this is the view that the software craftsperson will tell you. More recently, on the other side, though, you've got YouTube influencers in the coding space who will tell you, you know what, I've not been testing for years and I've been so fast, you can never catch up with me. I worked at Twitch, trust me, bro. And so you get these like different viewpoints, and you get people that are vehemently anti-testing, and you get people that are very, very pro-testing. And so as with many things in life these days, things get polarized to the very, very extreme. On the left, you've got the people that say, don't test, and if you test, don't ever talk to me again. And then on the right, you've got people saying, your code is bad, you should be testing every single bit of it. And really what happens is you've got this testing no man's land in the middle, where all nuance is lost. And they sometimes throw tomatoes at each other from either side, but really you don't get much nuanced conversations around a pragmatic testing approach. And I fancy myself a bit of a centrist. I don't stand for anything. So I'm aiming to annoy both parties with one talk. We'll see how this goes, okay? A little bit of, let me set the scene a little bit. So a couple years ago, I was working on a React Native project in the fashion industry. The app was going to be used in warehouses where they were going to scan items of clothing with a barcode scanner inside of the app, and it would store some information. They could enter in some information about the article of clothing, and it was being used by the back office effectively. There was a developer on my team who was working a lot on the front-end stuff, and she came to me at one point and was like, I'm trying to write a test for the barcode scanner. Basically, what I want to test is every single barcode has a checksum. The last few digits will be a sum of some of the values in the middle in some sort of mathematical formula. So I want to test that. But the challenge that she found was that she was needing to do so much setup before she could actually test that by rendering the screen. And what do I mean by that? I've actually went and extracted the code, and you'll see how horrifying it is in just about a second. But this screen initially had a bunch of different contexts, and we didn't really need them for the screen itself, but it needed to be mocked so that they could go ahead and test it. Cool, so that's a bunch of mocks. Then some of the clients needed to be mocked for the fetch requests. Expo's barcode scanner, which was an external library that uses the native device, needed to be mocked as well because you didn't have access to that in unit tests. Your navigation framework on the native layer needed to be mocked. All right, that's more mocks. Afterwards, we wanted to spy on alert, which is the native alerting functionality within React Native, another bit of functionality. And then it just kept going on and on and on. It's just like so many mocks before you actually test what you fundamentally wanted to test, which is the core business logic, right? It's really not a good state of the art when you're testing like this. And so she asked me a very good question, which was, does it always have to be so difficult? And it got me thinking about the overall architecture of our code, right? And it leads to a very good question, which is like, what is code architecture? And I really like this definition. So architecture are the decisions that you wish you could get right early in a project. It's a quote from Ralph Johnson, who's a computer science professor in the US. He's written several books around good software architecture. And one of the fundamental concepts that you'll learn within software architecture is this idea of separation of concerns. Right? So this idea with separation of concerns is that you can take different components within your application and you try to break them up into individual modules or chunks that are each individually responsible for a single distinct job. And they can do that independent of all the other bits. That's the theory. So the examples that you get is like the split of HTML, CSS, JavaScript in the traditional web, or the IP stack, which is in almost every single computer science textbook, which is like you've got all these layers to the network stack, and then you can take one out and replace it with something else, and in theory, the rest of the system should work fine, right? Now, we're in React world, and React is a little bit at odds with separation of concerns. What do I mean by that? So React's fundamental selling point and premise of JSX is actually premised on violating separation of concerns. It's this idea that you can bring in your markup into your interactivity layer, start writing HTML-like syntax to represent your UI within JavaScript. So it violates that old traditional mindset of separation of concerns that your HTML does your markup, your JavaScript does your interactivity, and your CSS does your styling. And the rest of the ecosystem kind of follows suit. You have libraries like style components, which lets you do your styling within your JavaScript as well, this whole concept of CSS and JS, right? So we're bringing all these things together. And this is great, by the way. I'm not negating the fact that this is actually a great addition to have as a framework because it makes things so much quicker and so much easier to understand with this component-based mindset. But what it means is that you can put everything kind of in one place and it all just works. So I have the most basic counterexample that you can think of. It's in React Native, but it's the same with React. You have at the very top, you have your interactivity. So it's the use states that you have, the callbacks that you have to increment the counter. But at the bottom, you've got your presentation layer. So you've got your markup and your styling. And if you add a styling framework like Tailwind into it, you've basically got your styling, your markup, so your UI structure, as well as your interactivity, all in one single file, right? So separation of concerns becomes a bit more muddled there. Take it, you're not meant to read this code, by the way, don't try, there's no point. But the idea here is like, if you add a little bit more functionality and keep it within the same component, just by like fetching a name of an article and having the button refetch, these files become larger and larger and larger. And as you start to make these components more and more complex, the testing also becomes harder because you're adding all of these different dependencies into a single component or a single screen. And this is by far the biggest challenge that people face, I think, when they're designing their architecture. And it's that React doesn't actually stop you from creating these large components that are not modularized correctly. You end up sort of coding yourself into a corner if you're not consciously thinking about how you split your component boundaries within React. So let's burn this up and look at where this actually goes. A usual symptom that I've seen in code bases, and we've been going on to a lot of different brownfield code bases that you see out in the wild, is that you have these massive React files with hundreds, or in some extreme cases, even thousands of lines. And in most cases, these components end up being hellish to test as well. So this isn't a news problem. People have been building GUIs since the 1980s, right? How did people deal with this when testing was a challenge? If we go back to the drawing board and we take a step out of the JavaScript world, there's been a lot of work that's been done by people in other languages and other frameworks to look at the architectural space and address some of these problems. So you might have heard of terms like model view controller. You might have heard of the term called humble object, which we're going to dig into a bit more today. The model view presenter. Its very close cousin, the model view view model. All these great names, right? You'll love this one. Look at that. The view interactor presenter entity route, it's really very catchy. Viper for short. Now, we're not going to go into all of these. We're going to actually just dig into two architectural patterns that I think are actually very helpful in the React space. Let's start with the humble object model. So let's say we have a component, and you want to actually test this component, right? A typical React component can have many things within it. On one level, you can have infrastructure code. What do we mean by that? It's fetching stuff. It's external services. Maybe you're calling a Sentry. Maybe you're calling your Google Analytics. They can all live within a component, and they sometimes you'll find that they do in the wild. You can have business logic, things like transformers, rules that you may have in your code, different flows of logic. You can have UI state and logic that is inherently related to rendering. So that's your form fields, your validation rules, so on and so forth, maybe some interactivity that goes into play. And lastly, you have the actual JSX and the styling. The humble object model is trying to aid with this problem that you may have, which is when you try to test this component in its entirety, it's actually quite complex because you need to mock a bunch of stuff, mock your external dependencies, and maybe you don't want to actually test all of this. If we think about what we really care about testing as the base level and the fundamental level, we really want to test the business logic more than anything else, right? In the case of our barcode scanner, what we care about testing is making sure that the checksum function works well. That if there's a duplicate and two barcodes match each other, that we throw an exception and we throw a validation rule. So what the humble object model says is take that out of the component and separate it out into its own module or file or whatever have you, and put your business logic, put the important bits of your logic inside of that. And instead of testing the actual component directly, you can instead test the humble object. And when you test that, it's a lot simpler and there's a lot less pain associated to it. So let's go ahead and look at a coding example for this and see a before and after. Cool. All right. So we've got a very basic app set up here. It's a meal prep delivery checkout page. So it's not very well designed, but what you basically have is you have a checkout page, and it has some logic that's added into it. So you have some level of discounts. If your total ends up being more than $50, you get a discount. So you can see once I drop below $50 and I'm on 37, the discounts disappear. And you can fetch and add more items if you're still hungry and want more items added. Other bits of logic that are interesting here is your shipping costs will go up and down depending on your total. So if you're getting less than $20, I think you end up incurring a shipping cost of $5. And you'll also see that the estimated delivery date changes depending on how large your basket is. So we've got a bit of front-end logic that's living here. Let's go take a look at the code. So if we start here, it's a very basic setup. Inside app.jsx, you can see a component that's not even that long compared to what you might see in the wild. It's about 110 lines. Hands up if you regularly face components that are around 100 lines long in React. 200 lines? 600. OK, we've got a winner. All right. 600 is the benchmark. Cool. So there's a lot that's going on here. We're going to quickly run through them. You've got an isTomorrow function. These are just some helper functions. They're utils. You've got a function to get the delivery date depending on the number of cart items. You've got a generate delivery label. So what this does is it checks, is the date tomorrow? If it is tomorrow, just say tomorrow. Otherwise, what I want you to do is render the date in a very specific format. And then you've got the actual React component underneath it. You've got shopping cart, which keeps in state the cart items. You've got a use effect to fetch the starting basket. And then afterwards, you have a reducer to check what the total is. And then you can discount items depending on if the total is more than $50, so on and so forth. And then you've got functions for handling the removing of an item and handling the adding of an item, which fetches another API call. And at the very bottom, we've got the lonely rendering logic, which has got the actual JSX, right? Now, a lot of this is really core business logic. So if you want to test this, and we'll go into our app.test.jsx, which is just a vtest test here. Let me zoom in a little bit. Forgot to ask, can everybody see and read the code clearly, right? Cool, thank you. So what we've had to do at the very, very top level here is we've had to mock the fetch. And then the way that, let's say we wanted to test whether or not a discount gets applied for more than $50 of basket, because that's the core logic that we're testing here. What we've done is we've rendered the shopping cart. And then afterwards, we're doing a query selector to check, is there text that has a strike-through applied to it that says $10, which is the first element in our mocked price. And then we're testing it. So in a weird roundabout way, what we've actually cared about testing is very different to what we've actually tested, which is we've tested UI with the goal of validating that our business logic works, right? It's just kind of unintuitive. But what we can really do quite easily is we can take a lot of that and make it into a humble object. And you'll see that the tests are far easier, but also the code looks a lot cleaner. So let's go here and we'll see the shopping cart now. So we've got none of those helper functions above, but we've got a payments that we keep on calling to actually do the business logic transformation. So let's take a look at payments.js and see what's there. You can see it's just a bunch of simple JavaScript functions. We've got an apply discount that takes in the items. We've got a calculate total that takes in the items and runs a reducer on it. You've got calculate shipping costs, which is just a very simple ternary within it. Like everything has become very functional small bits of business logic that we've included here. And then at the end, we just return that as a module itself. And if we go back to app.jsx, what we can see is all we do in our React component is we just start to call these functions that live in our payment service. And that's pretty much it. And then at the very bottom, we've got our actual JSX that's rendering. And when you go into the test file, you'll see it's very basic testing now. You're testing JavaScript. You're not having to worry about the asynchronous behaviors, or you're not having to worry about the component lifecycles. You don't need to use testing library to test the core business logic that you have. It's very simple. So What that ultimately means is you spend less time writing the tests, and you can write more effective tests because you're directly checking the business logic. So we've got apply a discount for more than $50. It's very simple. You pass it in an items array, and it returns the items with an added attribute for the discounted price. And then some more stuff about like no discount for less than $50, and the delivery label test. We're really just checking the function that takes in the items and returns the string for what the label is going to be. So we're testing what's really fundamentally important to us. Cool? I need to stop mirroring. Cool. So that is the humble object model. Let's look at the model view presenter. So this is a MVC-like architecture that GUI libraries will use. And it's basically separating out parts of your GUI. You've got the model, which contains the business logic. It contains data fetching. And then you've got the view. Now, what we do here is we make the view a passive view. What that means is the view itself doesn't have any of its like UI state or logic. All it does is it's kind of like a function. It takes in an input with certain values, and it renders accordingly. It's very functional in the approach that it does. And in the middle, between the model and the view, what you slot in is you slot in a presenter. The idea with this presenter is that this presenter will contain all of your UI state. It'll handle converting the UI state. It'll handle converting the model data to a format and a shape that matches what you want to render in the view. So what does that mean in practice? If we look at our example here again, we've taken everything and put it into a humble object. What this also means is we're going to take the infra code and also the UI state and logic and also take that out of the component. And what we're going to do is we're going to put it inside of a hook that lives outside of the component itself. And this is going to be use component, whatever your component would be called. And it'll contain the infra code, but also your UI state and your logic. And it'll also make the references to your humble object as well. And now at this point, it's really at your discretion what you want to test. You could test the hook, or you could test the actual UI component if you really wanted to make sure that the UI behaves in a certain way. A simple way that we kind of talk about this, especially with the rest of the team, is a simplification to say you have a one hook per screen rule. What that means is each component or screen should only be calling a single hook at any time. And you abstract away all of your UI state and logic into that hook. And it really makes it functional. And we'll take a look at how we evolve our coding example to handle this. Cool. So same exact app, but we're going to actually look at the MVP model. So we've abstracted away our humble object into payment. Let's go back into app now and see what it looks like. So what we've done is we've created a hook called shoppingcart.hook.js. It's called use shopping cart. That's the page that we have. And all of the top part of the component has really just been moved over here. So we've got our use state here, the use effect to populate the values, the calls to the payment service is moved here as well, so to the humble object, and then our callbacks to remove and add items. And then we've actually calculated the shipping costs. And what we do is we return an object in this hook, in this custom hook, that's got the transformed items, it's got the total, and everything else that we need in the UI to actually render correctly. And we'll go back into our app.jsx, and it's actually dropped down to about 38 lines. And all it does is it calls this hook and gets the data that's required to render from the hook, and then it just renders it very simply. It's very functional. It's in and out. And that's all that this does. And so what that actually fundamentally means is we still have our payment tests. We've tested all of the business logic. But separately to that, if we did want to test how the UI looks, maybe we really wanted to make sure that the strike-through was rendered when the original prices are no longer applicable and you have a discount, what we can do is we only need one mock here. And this is really fundamentally important when you start to have these complex components that need analytics and Sentry and so on and so forth added in. You have a lot of stuff to mock. And by abstracting everything away into a hook, you always have at most one mock, which is the actual hook that you are passing into that specific component. And what we say to it is, in this case, just return this as the output of the hook. This is the data that I want my screen to get. And then all I'm doing is I'm rendering the app and then very quickly checking to see if this element exists within the DOM. Right? So it's far simpler to test it because you don't have to worry about mocking all of the dependencies. It's just here's the hook and here's the value that the hook is going to return. Cool. So why is this important? The idea with this is that you want to encourage your team and your developers to fall into the pit of success. So there's this great article that I would highly recommend reading, which is called Falling into the Pit of Success. It's by the co-founder of Stack Overflow. And he talks about how C++ is basically a pit of failure or a pit of doom. If you make one misstep in a C++ application, the consequences are massively dire, and it doesn't do anything to safeguard you or protect you from falling into the pit of doom. Whereas a good programming language or a good framework or a good architecture, a good code base will set you up for the pit of success. The idea is that you create these well-designed systems that makes it really easy to fall into good patterns. And you can still allow people to escape those good patterns, but you make it quite difficult to do so. So you encourage people to fall into the pit of success. It becomes very easy for them to be successful. Great, so let's do a recap, and my time is over. The 4 main points are, firstly, you want to encourage clean code and architecture, and it can really help you reduce the waste in your testing, along with all of the benefits that it gives you in terms of your code-based organization and scalability. If you isolate important business logic into humble objects, you can make it very easy to test the critical components to your app very quickly. Using a presenter layer can make easily testable passive views. That's another name for these views, is the passive views. And you can make it really easy to test those because they don't have any data dependencies. And lastly, and I think this is the key part, there will be a lot of more experienced developers here. You all know these concepts. These are fundamental things that you learn over the years of becoming a software engineer. But actually teaching these principles to your team and explicitly talking about them with your team will help you set them up for the pit of success and hopefully make it less daunting for them to test, especially when it comes to complex components. Thank you all very much for listening. That is my Twitter and LinkedIn in case you want to stay connected. And yeah, appreciate all your time.